In this podcast episode, hosts Balak and Jonathan Cohen engage with Dr. Lara B. Anderson, a professor of physics and mathematics at Virginia Tech, specializing in theoretical high-energy particle physics and string theory. The conversation spans foundational questions about the universe, including its hidden components, multidimensionality, the nature of reality, the possibility of extraterrestrial life, and the evolving role of artificial intelligence in scientific discovery. Through Dr. Anderson's expert insights, they explore both the known and the profoundly mysterious, from dark matter and dark energy to time, multiverses, and the future of knowledge. Dr. Anderson begins by describing her path into physics, inspired as a child by a Stephen Hawking-designed planetarium show about the origins of the universe. She explains that her work is theoretical, grounded in computer simulations and mathematical models that aim to understand the fundamental constituents of matter and energy and how they obey the laws of nature. She highlights the challenges of communicating physics to the public, emphasizing that scientific research involves formulating precise questions, testing ideas rigorously, and often encountering many failed attempts before progress is made. Her field relies heavily on mathematics, which she describes as the language that enables us to access and conceptualize realms of the universe far beyond direct human perception. The discussion shifts to the shape and size of the universe, focusing on its expansion. Using the balloon analogy, Dr. Anderson explains how all parts of the universe move away from each other without a central point, and how this expansion is understood as the universe growing in size, possibly into higher dimensions. She clarifies that while we experience 3 spatial dimensions plus time, string theory predicts the existence of additional spatial dimensions, potentially up to 6 or more, which are compactified or wrapped up at scales too small to observe directly. The analogy of a wire appearing one-dimensional from afar, but two-dimensional upon close inspection, illustrates how extra dimensions might be hidden. These higher dimensions can have complex shapes, such as toroidal or Calabi-Yau manifolds, profoundly affecting the physical properties of particles and forces. Dr. Anderson delineates string theory as an ambitious framework that seeks to unify all known fundamental forces, including gravity, electromagnetism, and the strong and weak nuclear forces, into a single consistent theory. Unlike the standard model of particle physics, which deals with 3 forces but excludes gravity, string theory replaces point-like particles with one-dimensional vibrating strings. Different vibration modes correspond to different particles, including the graviton, the quantum carrier of gravity, naturally emerging from the theory. The theory's mathematical consistency demands the existence of extra dimensions and predicts phenomena not yet observed, such as dark matter candidates and other exotic particles. String theory may also provide insight into dark energy and the accelerated expansion of the universe. One of the profound mysteries Dr. Anderson highlights is that the majority of the universe's mass-energy content remains unknown, referred to as dark matter and dark energy. These entities interact gravitationally, but are not made of ordinary particles found in stars and planets. Dark energy is thought to drive the accelerating expansion of the universe, possibly arising from the energy inherent in empty space due to quantum fluctuations, particles and antiparticles spontaneously appearing and annihilating. Understanding these components is central to grasping the universe's ultimate fate, whether it will end in a big crunch, a big freeze, or some cyclic rebirth. The episode also explores the nature of time, emphasizing that it is not a universal constant, but relative, dependent on an observer's motion and gravitational environment. Einstein's theories demonstrate that clocks can run at different rates, such as in the twin paradox, where one twin ages slower due to traveling near the speed of light. Near black holes, time dilation can be extreme. While popular culture entertains the idea of time travel, Dr. Anderson stresses that physics currently does not support consistent theories allowing backward time travel without paradoxes. The possibility of multiple time dimensions has been considered, but leads to breakdowns in consistent physics. Regarding consciousness and perceived experiences outside the ordinary linear flow of time, she regards these as outside the purview of current physics, but welcomes their conceptual intrigue. Dr. Anderson touches on the multiverse concept as an interpretation of quantum mechanics' probabilistic nature, where every possible outcome could represent a branching reality. While attractive in science fiction and certain theoretical frameworks, she views it as untestable with current methods and thus not yet a scientific question. Quantum mechanics, inherent uncertainty, and wave-like behavior create possibilities that challenge straightforward notions of reality and inspire ongoing debate about the foundational nature of existence. Regarding alien life, Dr. Anderson expresses a strong belief that the universe is likely teeming with life, given its vastness and variety. The apparent uniqueness of Earth and life here seems statistically improbable to her, echoing humanity's historical trend of dethroning Earth's perceived centrality. Life elsewhere need not resemble humans or carbon-based organisms strictly. However, carbon remains a superior element for building complexity. The question of why we have not yet made contact may be explained by vast spatial distances, the scale of time, or the intelligence and cooperation challenges inherent in surviving as a civilization. She is fascinated by what forms alien life and intelligence might take, and the implications for understanding cooperation, communication, and planetary stewardship. Dr. Anderson sees artificial intelligence, particularly recent advances in machine learning and large language models, as transformative tools in scientific research. She identifies that AI is now assisting in solving complex mathematical problems, generating new theorems and proofs, and accelerating simulations that once took prohibitively long. While AI today is not yet conscious or independently innovative, it is approaching capabilities that enable meaningful collaboration with human researchers, raising questions about verification and trust in machine-generated knowledge that might outstrip human understanding. The rapid pace of AI development is both thrilling and intimidating, given the ethical challenges and societal impacts. She underscores the importance of responsible use and equitable access to these powerful tools. The conversation briefly touches on parallels between brain activity, memory, and AI pattern recognition. The brain's tendency to reinforce familiar pathways explains repetitive behaviors and reactions to trauma. This analogy extends to AI systems, which also rely on learned patterns. Healing and growth involve the formation of new neural pathways, suggesting that consciousness and experience, though complex, are still governed by physical systems. Dr. Anderson emphasizes that while AI offers a new layer of creativity and problem-solving, human consciousness remains uniquely complex and nuanced. On a more technical note, Dr. Anderson shares aspects of her research into the shapes of extra dimensions predicted by string theory. These compactified dimensions can take on highly intricate forms known as Calabi-Yau manifolds, among other exotic geometric configurations. The exact shape influences the types of particles and forces observable in our universe. Determining whether there is a finite or infinite set of possible shapes remains an open question. Understanding these geometries could unlock explanations for dark matter, unify forces, and pave the way for new physics beyond the standard model. Toward the close, Dr. Anderson reflects on the idea of a personal superpower, choosing the ability to pause time so she could manage the demands and busyness of life more effectively. This wish resonates with the overarching theme of navigating an expanding universe and rapidly changing technological landscape, emphasizing the human side behind abstract scientific pursuits: curiosity, inspiration, pressure, and the desire for balance.